Alright guys, so today we're doing the Unit 7 exam review. This is all things polynomials for the upcoming exam that you guys will be taking in my class on Thursday. So let's go ahead and get started with this video. The first problem that we're going to see here says to develop a polynomial that has the following solutions: 4i, negative 4i, and 4 with a multiplicity of 2. So what this means here is that we're going to have three different factor sets, right? We're going to have the x minus 4i, and you'll recall I is the square root of negative 1, okay, and that satisfies that first term. The second one says negative 4i, so that means that we're going to have x plus 4i. And lastly, if 4 is a factor, that means that we would have x minus 4 with a multiplicity of 2, which means we have this squared. So this would be y equals. And we're going to want to expand this. What I'm going to do first is I'm going to work on this group here. I'm going to chunk this and this one here, and then we'll combine. So for the first one, we'll set up our box, right? You guys will recall we can use the tabular method to solve this here. So we're going to say x minus 4i and x plus 4i. So x times x squared. X times 4i is 4xi. X times negative 4i is negative 4xi. And negative 4i times 4i would be negative 16i squared. Okay? And so we know when we combine like terms, these two terms here, a 4xi and a minus 4xi would simplify out. So we would be left with x squared minus 16i squared. Now what's important to remember here is that I squared, okay, essentially we have negative 1, the square root of negative 1 being squared. So I squared is negative 1, we would have x squared minus 16 times negative 1, which would give us x squared plus 16. And so all of this satisfies this first part here. The next part that we need to do, okay, and let's go ahead and just box this so we know where it's at, because we're going to use this in just a little bit, okay, is using the tabular method to multiply x minus 4 with x minus 4. X is x squared, x times negative 4 is negative 4x, x times negative 4 is negative 4x, and negative 4 times negative 4 is positive 16. So we would put these two factors together. Those do not simplify out. We have negative 4x minus 4x. So we end up getting x squared. Negative 4x minus 4x would be negative 8x plus 16. And here's our other factor set. Now, these two now are being multiplied. Oh, okay. So we got to set up one more box, right? Because this is this guy here, and we're now multiplying everything that we have here. Okay. So we'll do x squared plus 16, x squared minus 8x plus 16. So x squared times x squared is x to the 4th. X squared times negative 8x is negative 8x to the 3rd. X squared times 16, okay, is 16x squared. Okay, go ahead and copy that down there. And then we have 16 times x squared, which would be 16x squared. 16 times negative 8 Well, 8 times 16 would give us 128, so we'd have negative 128x. And then 16 squared, well, because 16 times 16 would be 256. We need to identify that we are going to have some like terms, right? We have this guy and this guy. So our final answer here would be x to the 4th minus 8x cubed. 16 squared plus 16 squared would be a positive 32x squared minus 128x plus 256. There you go. So to recap this one, because this was a little bit of a lengthy problem, it's asking us to find an equation, okay, to develop a polynomial that has the solutions of 4i, negative 4i, and 4 with a multiplicity of 2. So that first factor is x minus 4i, that satisfies 4i, x plus 4i, which satisfies the negative 4i, and x minus 4 squared, because our factor is 4, but we want a multiplicity of 2, which means this is happening twice. Okay, so what I did first is I multiplied the two imaginary sets. We got this side here. Then I multiplied the x minus 4 squared. Once I did that, I took these two, this one here, and this one, and multiplied those, because everything is just being multiplied to get our final polynomial. Okay? So let's go ahead and move on. You will now have your problem set. Okay? So with your problem set, I'll help you guys out here. It's the same idea. To do a factor of 2i would be x minus 2i. To satisfy negative 2i, we would have x plus 2i. And to satisfy 2 with a multiplicity of 2 would be x minus 2 squared. And so then what I'll do is I'll stop here on this problem, and you guys will be able to solve this solution. So if you have any questions or concerns, send me a message on Teams to let me know. But let's go ahead and move on. For the next one, it says complete the following polynomial division. Okay, so we're going to be doing some polynomial division here. The first thing I want to do is I want to write out this equation that's being divided, right? Well, notice though that I am missing a couple of factors here. I don't see an x cubed, and I don't see an x in there. So you'll recall from that lesson, when we don't see those values, we need to then address them, but with a 0. So what we'll see here is we'll see 5x to the 4th plus 0x cubed minus 3x squared plus 0x minus 3. And we're dividing all of this by x squared minus 2x plus 1. Okay, so the first things first is I want to come up with a factor times x squared that would give me 5x to the 4th. Well, that would be 5x squared, right? 5x squared times x squared would give me 5x to the 4th. Don't forget, we then take this and multiply it with negative 2x. We get negative 10x to the 3rd. And 5x squared times 1 would be 5. So it would be a plus 5x squared. Now we are subtracting, which means that this becomes a minus now. This now becomes a plus. And now we have a big fat minus here. So 5x to the 4th minus 5x to the 4th simplifies out. 0x cubed plus 10x cubed is 10x cubed. 3x squared minus 5x squared would be a minus 8x squared. And then we bring down our next term, which would be a plus 0x. So now we need to identify a factor multiplied by x squared that would give us 10x to the 3rd. Well, that would be a plus 10x, right? 10x times x squared would be 10x to the 3rd. 10x times negative 2x would be negative 20x squared. And 10x times 1 would be a plus 10x. And so we have subtraction, so this becomes a minus. This negative 20x squared becomes a plus 20x squared. And this 10x becomes a minus 10x. So 10x cubed minus 10x cubed simplifies out. Negative 8x squared plus 20x squared is a 12x squared. And 0x minus 10x is a minus 10x. We bring down our last term. And so now we want to find a factor multiplied by x squared that would give us 12x squared. Well, that would be a plus 12, right? Because 12 times x squared would give us 12x squared. 12 times negative 2x would be a negative 24x. And 12 times 1 would be a plus 12. Okay. So let's go ahead and identify that we do have to subtract these. So this will become a minus 12x squared, a plus 24x, and a minus 12. So 12x squared minus 12x squared simplifies out. Negative 10x plus 24x would be a positive 14x. And then negative 3 minus 12 would be a negative 15. And so this is our remainder. You'll recall when we take a remainder, we then just have to set that up being divided by our divisor, which is that x squared minus 2x plus 1. So our final answer for this would be 5x squared plus 10x plus 12 plus 14x minus 15 all over x squared minus 2x plus 1. And there you go. So to recap on this, and be very careful here, you're going to have to make sure that you satisfy that, because we don't have an x cubed in here. You represent that as a 0x cubed. And then the negative 3x squared. And we didn't have an x value here. We still need to identify that with 0x. And then follow it up with the minus 3. And then divide it using the same division rules that we used in class. Okay. Let's go ahead and move on. So when you're doing this problem, hint, hint, you are missing two values. If you get lost, please use the example that I had in the previous slide. Okay, this is division. You should have a remainder. If you have any questions or concerns, please let me know, and I'll be more than willing to help you guys out. Let's go ahead and move on. So the next one says here to multiply the following polynomials using the tabular method. In other words, using the box method. Okay, that's pretty straightforward. The only issue that we have is we'd say 3 by 3, right? Because we have a trinomial times a trinomial. So let's go ahead and set that up. I have a rather large box here. Okay. All right, 3 by 3. So we'll have 2x to the 4th plus 3x minus 4 times 3x squared minus 6x plus 2. So to get this first box here, we're going to have, oh, I'm sorry, this should have been a squared. 2x squared times 3x squared would be 6x to the 4th. 2x squared times negative 6x would be a negative 12x cubed. 2x squared times 2 would be 4x squared. 3x times 3x squared would be a 9x cubed. 3x times negative 6x would be a negative 18x squared. To get the square here, we'd have 3x times 2, which would be 6x. 3x squared times negative 4 would be a negative 12x squared. Negative 4 times negative 6x would be a positive 24x. And lastly, negative 4 times 2, which would be a negative 8. We then want to identify all the terms that are being combined. So we have these. Remember, these usually go with the diagonals. These three terms. And then lastly, these three terms. So our first term that we'll pull out here would be our 6x to the 4th. We then want to do the combination of 9x cubed minus 12x cubed, which would be a negative 3x cubed. Then we have negative 12x squared minus 18x squared plus a 4x squared. So negative 12x squared minus 18x squared would be a negative 30x squared. And 30x squared plus 4x squared would be a negative 24x squared. Okay. Then we have 24x plus 6x, which would be a positive 30x. And then lastly, negative 8. And this is using the tabular method, also known as the box method, to multiply these two polynomials. Okay. Let's go ahead and move on. This is your problem here. It says to do the same thing, multiply the following polynomials using the tabular method or the box method as you know it. So you are going to have another 3 by 3. Please take your time and then make sure that you identify the correct terms that you need to combine. If you have any questions, let me know. Let's go ahead and move on. The next one says to state the polynomial, the leading coefficient, and the degree of the polynomial. Okay, cool. So to state the polynomial, we're going to look first and foremost, okay, at how many terms we have, right? And the degree. So we have this here. We know that if we start off, we could have constant, linear, quadratic would be x squared, but we go up to the third power. So a third power means that this is cubic. This is the type of polynomial we have. It's a cubic polynomial. The leading coefficient is the first coefficient that we see here. We have a negative 1. So our leading coefficient is equal to a negative 1. And our degree is a 3. It's the largest exponential value. So degree of 3. Let's look at this next one here. I'm going to look at the degree, which is a 4. So this tells me because it's a 4, it's going to be a quartic. Okay, quartic polynomial. Our leading coefficient, we'll just abbreviate this leading coefficient, is going to be this 1 that we don't see here. And we have a degree of 4. And that's it for this one. Pretty cut and dry. Okay. You'll remember, and just to help you guys out here, because I know this might come up, if we see a degree of 1, let's say degree 1, that's going to be a linear. Degree 2 would be quadratic. Degree 3 is cubic. Degree of 4 is quartic. Degree of 5 is quintic. And 6 plus is just referred to as a polynomial. Okay, we did skip 0. We're not going to be dealing with constants. Okay. All right, so let's go ahead and move on to the next problem. This is going to be yours, so you're going to want to make sure that you identify first the degree. That degree will tell you what type of polynomial this is. You then want to identify the leading coefficient, and then lastly, just restate that degree. Okay, let's go ahead and move on. So this one says here, using the reverse tabular method, identify the shaded term while solving. Okay, so wow, okay. So this is big. We haven't done a big reverse tabular method like this before. We are going to be dividing this top initial, right, this numerator, 6x to the 4th plus x to the 3rd, plus 25x squared plus 11x plus 21 divided by 2x squared minus x plus 7. So we know that we're going to have the factors of 2x squared here minus x plus 7. And we take the first term, that's 6x to the fourth, and we can take our last term. All right, the first term always goes in the top left, the last term always goes in the bottom right, and then we can start solving for our terms up here. So to get this one here, we gotta think of some term, some factor times 2x squared would give us 6x to the fourth. Well, that would be 3x squared. Oh, okay, cool. So this is 3x squared. We know this to be true. Okay, so then I can solve for these last two factors here in this column. So I can do 3x squared times negative x would give me negative 3x cubed. 3x squared times 7 would give me 21x squared. Okay, well, we still don't have this in the shaded region. That's okay. We'll get there. We'll get there. We can then solve for this factor over here. Okay, because we can determine that some number times 7 gives us 21. Well, that would be a plus 3. 3 times 7 is 21. So then I can solve for these factors here. 3 times 2x squared, which would be 6x squared. 3 times negative x would give me a negative 3x. 3 times 7 is 21. Done. Okay, well, we still don't have these factors here. So what we need to make sure that we identify is these two here. This is where it gets tricky. These two here have to give me this positive x cubed. They have to equal x cubed. So if that's true, okay, some number minus 3x cubed has to give me 1x cubed. Well, that would be 4x cubed, because 4x cubed minus 3x cubed is 1x cubed. Okay, okay. That means that I can solve for this factor up here. All right, I can solve for this guy now, because some factor times 2x squared should give me 4x cubed. Well, that would be a 2x, a positive 2x. Okay. So then now I can solve for this gray square. I can do 2x times negative x would be negative 2x squared. Now I want to just make sure that I'm doing this correctly. If I combine these like terms of these three terms, okay, I should get 25x squared. Well, let's see. 21x squared minus 2x squared, which would be 19x squared. 19x squared plus 6x squared is 25x squared. So this is correct. So then our solution to this would be negative 2x squared. Because again, they weren't asking us for the, like, what is the answer here? They want to make sure that we identify this middle term. So to recap on this one, because this is a rather long problem here, okay, we set up our reverse tabular method. We have our terms here on the side as what we're dividing by, that 2x squared minus x plus 7. We know that that first term in the numerator, that 6x to the fourth, will go to the upper left. The 21 goes to the bottom right. And then we just start solving for the factors. Please, guys, if you get stuck on the next problem, use this video, rewind, and look at my steps here. Okay? So on the next problem, you have the exact same thing, just different values. Okay? I will get you set up on this, but then you guys will do the rest. So we're dividing by that 2x squared minus 3x plus 7. Your first term here, that 4x to the fourth. Okay, we'll go in here, 4x to the fourth. And your last term, the 7, over down here. I personally would solve for this first, up here, do these parts in the same column, and then do this one, and then you can use the like terms to solve. If you get stuck, look at the previous problem, use that to guide your learning. But then if you just absolutely cannot, send me a message and I'll be more than willing to help you guys out. Let's go ahead and move on. So it says determine the factors of multiplicity for f of x equals x to the fourth minus 16x cubed plus 64x squared. So this is a timed exam, guys, and you have access to Desmos, so use Desmos. What I did here is I put that equation into Desmos and I identify that I have a 0 here at 0, 0, and I have another 0 here at 8, 0. Now if you look at here, they're both bouncing, okay? They're both bouncing, which means that I have an even multiplicity, okay? Again, I have an even multiplicity, okay? Which means that it's either going to be a multiplicity of 2, 4, 6, or 8. Looking at this equation, it can't be any higher than 4, and I can already see that x squared is going to be factored out. So what ends up happening here is I have x equals 0 with a multiplicity, we'll just put multi of 2, and I know it's a multi of 2 because it's a bounce. Had it crossed through at 0, okay, I know that it would have been an odd multiplicity of either 1 or 3. Next, I have a multiplicity of x equals 8 with a multi of 2. Okay. Now, if you wanted to do this by hand, which I'll do real quick, you can say x to the fourth minus 16x cubed plus 64x squared. We can factor out an x squared, which leaves us with x squared minus 16x plus 64. Okay. We can still leave this as x squared, and then this trinomial would break down to two binomials, x and x. Two numbers multiplied, they give me positive 64, but added together give me negative 16, well, that would be negative 8 and negative 8. So if I solve for these, we'd have x squared equals 0, which means that x equals 0 with a multi of 2, right? Okay, because this happens twice. And this x minus 8, so x minus 8, we set that equal to 0, we get x equals 8, but that happened 1, 2 times, so that's a multi of 2. Again, this is doing it by hand, by factoring. I prefer you do it this way, but for the sake of time, if you need to use Desmos, you can use Desmos to identify these. Just remember, if it bounces, it's an even 2, 4, right? It's not going to get any higher than that. We're not doing any polynomials bigger than that. Or if it's odd, 1, 3, it's because it's crossing. Okay, let's go ahead and move on. You have the same thing here. I want you to determine the factors. You can either actually factor this, or you can use Desmos. You will have more than one factor, and just make sure that you identify the correct multiplicity. Let's go ahead and move on. So this one says here, use the rational root theorem to create a list of possible rational zeros for the following equation. So now, I apologize, we didn't spend any time on the rational root theorem. We ran out of time in this unit before we got there. And so just to give you a quick rundown, you're going to always be looking at the last term over the first term. And it's going to be the factors. So what I mean by that is we're looking for the factors of 20, because he's the last term. All right, that 20 is going to go here. Divided by the factors of, well, I don't see a number here. Well, because it's a 1. And when we talk about factors, it's like what numbers multiply that give us this. So that would be to get a 20 would be a plus or minus 1 and a plus or minus 20. Because 1 times 20 is 20. We could also do negative 1 times negative 20 is also a positive 20. Another set of factors would be plus or minus 2 and plus or minus 10. 2 times 10 is 20. Negative 2 times negative 10 is also 20. And then lastly, plus or minus 4 with a plus or minus 5. Because 4 times 5 is 20. Negative 4 times negative 5 is 20. And this is all divided by the factors of the bottom number. Well, our factor of 1 in this case is just plus or minus 1. Okay, so if we were going to list out these numbers, like all of our possible answers to this, it could be, and then we'll go from least to greatest, okay, because they're all being divided by plus or minus 1. It doesn't really change the plus or minuses here. We would just end up with negative 20, negative 10, negative 5, negative 4, negative 2, negative 1, but then we also have 1, 2, 4, 5, 10, and 20. And these are all the possible values that x could equal. Again, that was the rational root theorem. We did not have time for that in our lessons. It was scheduled, but with testing and everything, this is the lesson that I did cut because I felt like it was pretty easy to go over it. Again, you just take the factors of the last term, which was 20, divided by the factors of the first. And this gives you all possible solutions. It doesn't mean that these are the answers, it just means that they're possible solutions. So looking at this one here, we're doing the exact same thing. We're using the rational root theorem. So we're going to be looking at the factors of 15, because that's the last term. So we'll put here factors of 15 divided by factors of 1, right? Your 1, your 15. Okay, and I'll let you solve for those factors. Remember, factors are being what two numbers multiplied give you 15. You want to identify both the positive and the negative. And you can do that just by listing it as plus or minus. Okay, if you have any questions or concerns, send me a message. I'll be more than willing to help you guys out. Let's go ahead and move on. And so lastly, determine the zeros of f of x equals x cubed minus 10x squared plus 27x minus 18. This is a Desmos problem, guys. Don't try doing this by hand. That's going to be a lot of factoring. We could do this by grouping. We're not going to do that, though. You can easily just put this into Desmos, and we look at our solutions at 1. We have another one here at 3. And our last one here at 6. So your answer should be x equals 1, 3, and 6. And there you go. Okay. And lastly, the last problem that we'll have here, you'll do the exact same thing. You'll plug this into Desmos. Just look where your graph crosses the x-axis and identify those points. Okay, guys, that's going to go ahead and finalize our quick exam review for Unit 7 on polynomials. Please take your time to complete this. This review is for a grade. It's actually going to be the last grade for the quarter, and your exam will be the first grade for next quarter. So you want to make sure that you guys complete this and do your best on it. If you have any questions or concerns, let me know, guys. Don't flounder on this. Help each other out as well. And we'll see you later. Best of luck. Thank you, guys.